Hi, welcome back to my channel. This video will be about two things. Number one, importance of reinforced concrete design to civil engineering. And number two, materials and mechanical properties of concrete and of steel. As mentioned, this discussion would cover course outcome number one, and this will be part A of the discussion. CO1 includes Introduction to Reinforced Concrete Design, Working Stress Design Principle, and Concept of Pre-Stressed Concrete. To start, we should know the importance and relation to civil engineering. So by this lecture, we would be differentiating a concrete versus a reinforced concrete. And knowing those information as we proceed would be important in relating properties of your concrete, properties of your steel, and how they work together. Concrete is a mixture of sand, aggregate, gravel, and crushed rock. Using cement and water, when combined together, they create a rock-like mass structure. So when it hardens, it is like this. Ang ginagamit dito, it is in cubical form. Sometimes, it will be in cylindrical. And the good thing, as initial characteristics of your concrete, is it can be molded into variety of shapes. Sometimes, one or more admixtures are added to change certain characteristics of the concrete, such as its workability, durability, and time of hardening. So in case your concrete will be transferred from one location to another and masyado siyang malayo, so admixtures are used for the para madaya natin yung concrete, and yung time of hardening niya or yung retarding stage or retarding time would be hacked by your admixtures. Sometimes din naman when you lessen the amount of your water to your concrete, it actually incorporates to a higher strength. Pero because it is too dry or it becomes dry, so yung workability mas mahirap haluin, it is not easily to mold with. So these things can be changed or can be ascertained by your admixtures. So there are many admixtures present, and if you want to search for admixtures, might as well look for applications on how they are best fit for construction. In addition, cement content to workability and strength is an important one to remember. Why? There are many factors affecting strength of concrete, and knowing those is would make a difference. For a given workability, as here, an increase in the proportion of cement in a mix has little effect on the water demand and results in a reduction in the water-cement ratio. However, the reduction in water-cement ratio leads to an increase in strength of concrete. Also, therefore, for a given workability, an increase in the cement content results in an increase in strength of your concrete. So it's like a hierarchy. There are many levels that is comprised in terms of the characteristics and behavior of our concrete. And knowing those is very important when we're relating concrete, reinforced concrete, and your steel structures. Reducing water by definition and by practice and practicality, it would increase compressive and flexural strengths. It will lower permeability and increase water toughness. It would increase durability. It would reduce concrete drying shrinkage and potential for cracking. Those are taken from the 15th edition of the Portland Cement Association PCA. For further discussions or let's say more detailed discussions, you can check this book. Either you buy it online or there may be videos that could be tackling these types of scenarios when reducing water would result to things such as this. As with most rock-like substances, concrete has a high compressive strength and a very low tensile strength. But because concrete has been widely and vastly used in construction, we would like to address the concern or the pain in terms of tensile strength. Yes, maganda yung yung compressive strength niya, so okay yon in terms of pushing. Pero in terms of pulling, medyo mahina yung ating concrete. So for us to address this issue and for us to make a better material other than concrete, we introduce a reinforced concrete. Your reinforced concrete is definitely a combination. Is definitely an improvement of a concrete because now it is a combination of one, concrete, and two, your steel, wherein the steel reinforcement provides tensile strength lacking in your concrete. Steel reinforcing is also capable of resisting compression forces and is used in columns as well as in other situations. So in here, if this does not make sense yet, so expect as we proceed with the discussion, with the computation, and with the design and analysis of your concrete and reinforced concrete materials, this would now be more, you would now appreciate these images better. As a future civil engineer or licensed engineer, this course would enable you to understand vital information such as advantages and disadvantages of reinforced concrete as a structural material, comparison of reinforced concrete and structural steel for buildings and bridges, compatibility of concrete and steel. Knowing number one would mean that you can now weigh in. Knowing the advantages and disadvantages, the question now is whether to proceed reinforced concrete as a material. Knowing number two is comparison of RC and structural steel for buildings and bridges. There are instances that concrete and steel are competitive with each other in terms of the height and in terms of application. And knowing this comparison would strengthen and would make your decision making better in terms of your practice in the future. Number three, compatibility of concrete and steel. We would like to know the single properties or the individual properties of your concrete and your steel, and then we would like to make the compatibility of those two kasi they are combined together and so they are applied together in the industry. Kaya maganda pag nalaman mo tong tatlong to, you'll become a competent civil engineer who knows how to answer questions, who knows how to design and analyze your beams and other reinforced concrete elements. To start, advantages of reinforced concrete as a structural material. Reinforced concrete may be the most important material available for construction. The tremendous success of this universal construction can be attested by its advantages. Number one, it has high compressive strength. Number two, it has resistance to the actions of fire and water. Number three, it is very rigid. Number four, it is low in maintenance. Number five, it has a long service life. It is economical. It casts into an extraordinary variety of shapes. Using your formworks, you can now create cylindrical, cubical, rectangular, T-shapes, and other extraordinary variety of shapes with your reinforced concrete. In most areas, concrete takes advantage of inexpensive local materials and requires relatively small amounts of cement and reinforcing steel. A lower grade of skilled labor is required. So it doesn't matter if you are uneducated or if you are less educated. So I hope that's politically correct. That's the term, that term is politically correct. What we say is there are variations on academic achievement. So hindi siya nagiging matter kasi there is a lower grade of skilled labor required. And mostly, by practice, we know how to create it better. Disadvantages, however, of your concrete are low tensile strength. So mahina siya sa tension. Forms are required. So those are expensive. That's extra expense. Heavy materials. Your strength or compressive strength is force per unit area. So if you would like to have a bigger strength or a bigger force, you have to create a bigger mass. Similarly, relatively large as mentioned. Kung gusto mo ng mas malaki, the low strength per unit of volume of concrete means members will be relatively large. And as an important consideration for tall buildings and long span structures, ayaw mo naman na masyadong mataas yung weight or mabigat tapos masyado na siyang mataas. Properties of concrete vary. So from, let's say, 10 sets of people that would create a mixture, and then the mixture would be created in a single method. The results would still vary because there are many uncertainties and there are many factors affecting the relationship between your concrete, your steel, and then the performance of your concrete. That's why properties of concrete are varying. Continuing, we now compare reinforced concrete and structural steel for buildings and bridges. The question should we ask ourselves is, should reinforced concrete or structural steel be used? So in the academy, what we do is you take reinforced concrete and then you take steel design. Why? Because you have to have the knowledge on how you can compare the two, and then you can decide on your own which material to use, because there is no simple answer to the question a while ago. In as much as both materials have many excellent characteristics that can be utilized successfully for so many types of structures, and actually they work together beautifully. And some structures are using both your steel and your concrete together. The selection of the structure may vary depending on your local codes, your foundation conditions, and other considerations. Let's say for a building of less than 4 stories, your reinforced concrete, structural steel, a wall, bearing construction are competitive, or they could be your options. If in case we increase the stories from 4 to 20, it is now between reinforced concrete and structural steel. Mostly, it would be structural steel because of skyscrapers, or they are too high. So, ang nangyayari kapag masyado ng mataas, gusto mo na ng lightweight material. And lightweight material, as of now, are widely present on your high-performing steel but lightweight material. However, reinforced concrete now is becoming increasingly competitive above 20 stories, and you would now see buildings or structures that are using concrete on high stories. Compatibility of concrete and steel is the next discussion, because it's very important for students to know how these two are working together. And in layman's term, they work beautifully. How do we say they work beautifully? The advantages of each material seem to compensate for the disadvantages of the other. As mentioned a while ago, your concrete is low in tension strength, but your steel is good in tension. Vice versa with your steel and with your concrete. The yin and yang relationship between the two is a good thing, because these two material bonds together very well, so that there is a little chance of slippage between the two. Thus, they will act together as a unit in resisting forces. Investigation and design, however, is tedious in reinforced concrete. To properly do this, you must know the code and the provisions. Kasi it is good to know and good to be ready that understanding whatever you're doing, whether it's investigation or it's design, it should be based from the code. Currently, we have the 2015 version of the NSCP, which is the 7th edition, that is an incorporation of many codes taken from other existing parameters. We have the UBC 1997, we have the IBC 2009, we have the ASCE, ACI, we have the AISC, also we have your AISI, Reinforced Masonry Engineering Handbook of America is also on NSCP 2015 as a reference. Concrete Masonry Handbook 6th edition, and American National Standard Institute, and of course your ASTM standards. So when they are combined together beautifully, and they are combined together to act as a guideline or a code based, it is now what we call our National Structural Code of the Philippines, which is the 7th edition, year or dated 2015. Part of the introduction of reinforced concrete design is materials and mechanical properties of concrete and of steel. Properties of concrete is the first to be discussed, and then later we will be discussing properties of your steel. Why should you discuss this? A thorough knowledge of the properties of concrete is necessary for the student before he or she begins to design reinforced concrete structures. Number one is your compressive strength. It's actually written as F prime of C, but it's read as FC prime. This compressive strength would be used from this day up to the last topic of reinforced concrete. In definition, it is the capacity to withstand pushing forces that are actually directed. Ano yung actually directed? They are forces that are acting on the center of gravity of or the centroid of your material. It is also termed as the maximum stress a material can sustain under crushing load. The compressive strength, or FC prime, is determined by testing to failure a 28-day-old 6 by 12 inch cylindrical concrete cylinders, which is the normal size. The testing could be done in the 7th day, the 14th day, the 28th day. At the 28th day, we assume that it's already the maximum or the ultimate strength from 2,500 psi or pounds per square inch. It's the unit of stress in English, up to as high as 10,000 psi to 20,000 psi. But most concrete used to fall under 3,000 to 7,000. This 3,000 to 7,000 could be ordinary or it could be pre-stressed. Concrete gains strength with time after casting. So as time goes by or as time continues, your concrete gains better strength. For ordinary applications, it would range to 3,000 to 4,000 psi. But if it's now pre-stressed concrete, it would range to 5,000 to 6,000 commonly. The basic definition of pre-stressed concrete are concrete that are compressed during production, commonly used in construction. But this is a separate topic and it will be discussed in full details in relation to concepts and theories and general equations. So we'll just leave this simple paragraph to describe your pre-stressed concrete. However, if you are wondering what pre-stressed concrete is, you may watch a video in YouTube here. So this is not my video, but I've seen the video and it's I think it would be beneficial for students to watch, so you could have the supplementary answer to what is pre-stressed concrete. Other countries may be using 200 millimeter cube test specimens. For the same batches of concrete, the testing of a 6 by 12 inch cylinders provide compressive strengths only equal to 80% of the values in PSI determined with the cube. So by practice, yung cylindrical mold mo, it would only yield mostly 80% of the true value of your actual concrete. It is quite feasible to move from 3,000 to 5,000. The approximate increase in material cost is 15 to 20%. So if you want to increase the strength, most definitely you want to also change or increase your material cost. However, to move 5,000 to 6,000, it requires very careful mix designs and considerable attention to such details as mixing, placing, and curing. So aside from inducing an admixture, inducing a pre-stressed concrete methodology, you may actually create a good and considerable high-strength concrete when you are putting so much details on your mixing, placing, and your curing. Properties of concrete could be better explained in terms of your concrete stress-strain relationship. Assuming we have a force F that is in terms of compression, it's being applied, therefore, the material would now experience stress and it would experience strain. The first step is proportionality limit. Your material would reach proportionality limit. As you continue to increase your force, which is in compression, it would now go to your elastic limit. After elastic limit, as you continue to increase your compressive force, you'll now reach your ultimate compressive strength and your breaking point. This ultimate compressive strength is your FC prime. Your breaking point is as when or where your concrete cracks or it fails. Exactly half of FC prime is your proportionality limit. So at this region, it is linear in relationship. An increase would on your stress would directly be or linear in proportion to the increase or decrease on your strain. This is again in linear or elastic relationship. However, after the 0.5, your concrete now behaves in an inelastic or a non-linear portion. So this is important to know because as we proceed on a more or advanced discussion of your properties and materials, there will be instances that your concrete is linearly behaving or it could be non-linearly behaving. The common values for FC prime are 21, 28, 34. This is 3 KSI, this is 4 KSI, and this is 5 KSI. K is 1,000 pounds, meaning this is 3,000 PSI. The minimum FC prime as per NSCP 2015 is 17 megapascal. This is taken from 412.2.1.1 of your book. Conversions are, if you want to convert KSI to MPa, all you have to do is induce a multiplier or a correction factor of 6.895. Take note that 1 KSI is equal to 1000 PSI. Slope is the modulus of elasticity. Next is we discussed your Young's modulus. That's why we're getting the ratio between your stress and your strain. Sometimes it would be the symbol is capital Y, but for the sake of the discussion, would be using capital E. As again, as mentioned a while ago, it's the ratio between your stress and your strain. Normal weight of concrete, which is NWC, ranges from 2,300 kilogram per cubic meter. So how do we know the elastic or the Young's modulus of your concrete? Based from the code, which is section 419.2.2.1.b, it is 4,700 lambda FC prime. But what if your concrete is not weighing exactly 2,300 kilogram per cubic meter, or it's not termed as a normal weight? We now proceed to for any value or for values of weight of concrete between 1440 to 2560, you would now use Young's modulus of concrete equal to WC 1.5 multiplied by 0.040 lambda FC prime. This is taken from 419.2.2.1.a. So what is lambda? Your lambda here could be taken as 1.0 or 0.75. It will change when equal to 1 for for normal weight concrete, equal to 0.75 for lightweight concrete. Weight of concrete is normally 24 kilonewton per cubic meter unless specified. Review your knowledge on specific gravity or specific S multiplied by your weight of water is equal to the weight of your material. So in here, weight of concrete is equal to specific gravity multiplied by weight of water. If we use 2.4, say, that's the specific gravity of your concrete, and then we have weight of water equal to 9.81, exactly, your weight of concrete would be 23.54. But again, we assume it's 24 unless specified. Other properties of your concrete are as follows: dynamic modulus of elasticity, creep, shrinkage, tensile strength, even though if it's too small compared to steel, it is being determined by the modulus of your rupture. So the modulus of your rupture is termed as F sub R. It is in megapascal. On the code, it is 0.62 lambda multiplied by Fc prime. Before, what you can remember is Fc or Ft. That is stress in compression and stress in tension. Ito, dahil F sub R, meaning this is also stress in terms of modulus of rupture. But it can also be related to your bending stress, which is MC over R. So you can relate MC over I and equate that to 0.62 lambda Fc prime. But what is lambda? For normal weight concrete, it is equal to 1.0. Also for lightweight. For modification factors, aside from 1.0, you can check 419.2.4.2 of the NSCP. Next property is shear strength, and those properties that we skipped a while ago and now the shear strength could be your way to review on your own because they are less in terms of provisions on the NSCP. So medyo definition lang siya. So we will not take that into details. After concrete, you have now your properties of steel. Number one is your strength. Yield strength is the most common property of which the designer will need, as it is the basis used for most of the rules given in the design code. If your concrete's friend or best friend is Fc prime, your steel's best friend is your yield strength. The sizes of your steel varies in terms of diameter. It could be 10, 12, 16, 20, 25, 28, 32, or 36. If you are constructing a residential infrastructure or a residential building, maybe you can consider using 10 to 20 millimeter diameter. If it's a high rise, now we start using 25, 28, 32, and 36. Also, your steel can be categorized in terms of its length. It could be 6 meters, 7.5 meters, 9 meters, or 12 meters. There could be an increment of 1.5 per order on your local hardware. Other properties of steel that has less provisions on the codes are your toughness, your ductility, your weldability, your durability. We will not discuss this into full details, but they will serve as supplementary and additional learning for you to understand better the properties of your steel. Now, we jump to the stress-strain relationship of your steel. When you are discussing the stress-strain relationship of your concrete, the force is in compression. For steel, the force is in tension. So again, vertically, it's the stress. Horizontal, it's your strain. If you induce a tensile force, it will first reach your proportionality limit. Next is your elastic limit. You continue to increase your tension, it will now have a new point, which is your yield point. Unlike your concrete, your steel could undergo necking, or it would be sexy. Yung sexy na yon, yun yung yield point ng steel natin. Next is, for it to reach its ultimate strength, for concrete, its ultimate compressive strength. For steel, its ultimate strength. And then its rupture point. Aside from this rupture point, steel also have its second actual rupture point. And those are different. The other is making it suffer increasingly. The other naman is parang nagde-decrease na yung property ng steel mo. Common or commercial yield strength are as follows. It could be in ASTM, it could be in Philippine National Standard, PNS, or it could be in NSCP, or it could be color-coded. So depending on ASTM, 33, 40, 60 multiplied by 6.895, most definitely you would reach 230, 280, and 420. Tapos make a less adjustment, almost similar PNS. So all you have to do is be familiar with how they are being termed. Kung minsan din, ginagamitan natin siya ng color coding para mas mabilis siyang malabel. White is for 33, 230, and 230. Yellow is 40, 275, 280. And green is for 60, 415, and 420. This is very effective in grouping your reinforcements on site, especially when you are building a high-rise structure or a structure that requires a lot of reinforcements. There are 3 types as an advanced reading: hot-rolled, longitudinal bars, and pre-stressed cables. That are types of your steel reinforcement. The modulus of elasticity, however, of steel is not formula-based because now it is just equal to 200,000 megapascal. So why is it important for us to know the relationship or the values for your EC and your ES? EC again is the modulus of elasticity for concrete. ES is the modulus of elasticity for your steel. Because your reinforced concrete is heterogeneous material. It is comprised of 2 materials. One is concrete, 2 is your steel. It's important to relate your ES to EC, that is termed your modular ratio, so you can convert your area of steel to an equivalent of the concrete to make it homogeneous. And when it's homogeneous, it acts as one, and therefore it will now become a better analysis and determination for your properties of reinforced concrete design. So, importanteng malaman yung ratio ng ES and EC kasi ginagamit yung modular ratio for cracked and uncracked sections, or conversion or converting your steel to a concrete property. Before, on your mechanics of rigid bodies, that's the main idea for your modular ratio. Converting a stronger material to a less weak material. The next discussion would be introduction to reinforced concrete design, but that will be included on the next video. That would be course outcome 1, part 2. Thank you for watching. God bless and bye-bye.